Okay, here are notes again. I hope that worked out well for you the last time. Again, on this video, you can and should pause as often as you need to so you can keep up with understanding. You can rewind. You all know how to use YouTube, so use the features and really try and take the opportunity to learn and understand, not just get through it as quickly as possible. This video, might end up getting up to be around 15 minutes, but all you are doing today is taking careful notes and trying to understand. And this is an extension of what you learned in the last few days about how to deal with exponents. So we're going to be incorporating some of the same rules about how you add exponents when you're multiplying, how if you raise a power to a power, you multiply those exponents. So here we have what's called the power of a product. And you can see the rule right here. So if you have a product, so A times B is a generic product, meaning a multiplication problem, and you raise that product to some exponent, to a power, then that's really the same as if each of the factors, so in this case A is a factor and B is a factor, as each of those factors was raised to that exponent. So this looks a lot like the distributive property in that the exponent is given to each factor on the inside. And so we're going to see how this applies, and then as we go, it's also going to bring in some of the other rules we've learned if we have to combine things with the same base. So looking at number 1, 5x, and that whole quantity, 5x, is in parentheses to the third power. So what that would look like is really repeating what's in the parentheses 3 times. And then this is 5x times 5x times 5x. You could rearrange all this because it's all multiplication to be 5 times 5 times 5 times x times x times x. Now here we have 3 5s and 3 x's. That's 5 to the third, x to the third. So what the rule is, and what a shortcut would do, would be to say, if you have 5x to the third power, this 3 could go to the 5, this 3 could go to the x, and so it just becomes 5 to the third, x to the third. So the same answer is just a little bit quicker if you know that rule. Okay, so on to number 2. This is also going to bring up a very commonly misunderstood or mistaken thing when you have a negative number to an exponent. So the rule of the power of a product is 2 gets handed out to the negative 2 and to the y. So this is really the same as negative 2. And you need to put that negative 2 in parentheses because the negative 2 is repeated twice. And we'll see lots of examples of why that matters later. So that negative 2 to the second power times y to the second power would be your answer. Okay, now number 3, this illustrates why that negative makes a difference about whether the negative is inside the parentheses like it was on number 2, or whether it's outside of the parentheses like it's number 3. So what this really means literally is negative, but the negative is not repeated because the negative is not in parentheses, and then this becomes 2y times 2y. Or negative, so the negative is just sitting there once, it's not repeating twice, 2 squared y squared. So using the rule, we could have just said this 2 gets handed out to the 2 on the inside, the exponent gets handed out to the y on the inside, and we have our single negative, and then 2 squared y squared. So the negative is not repeated. Okay, moving on to number 4. Now we are going to use our power of a product. This is our new rule, and you're going to see that it also combines with the power of a power. So if this 2 gets handed out to the x to the 6th and it gets handed out to the y to the 3rd, what this is going to look like is x to the 6th squared times y to the third squared. And I'm using parentheses to kind of separate out the exponent of 6 and the exponent of 2. Now hopefully you remember your rule from yesterday. If you have a power to a power, so x to the 6 to the second power, what is the rule? Dramatic pause for you to all shout out. You multiply the exponents, so this is the same as x to the 6 times 2. This is the same as y to the 3 times 2, so we should be left with x to the 12th, y to the 6th. Now you'll notice I didn't write this little multiplication symbol between the x to the 12th and y to the 6th. Sometimes you'll see it written, sometimes you'll see it not written. It's just implied if you write them next to each other, and it means multiplication. Okay, number 5. You have 4, you have x squared, and you have y. And that's sort of like 3 different bases. You have a base of 4, you have a base of x, you have a base of y. So the 4 gets handed out to the 4, the exponent gets handed out to the x squared, and to the y. So this becomes 4 to the 4th power, x squared to the 4th power, y to the 4th power. 4 to the 4th is 4 to the 4th, x squared to the 4th is to the 8th because it's a power to a power, and y to the 4th. Okay, on number 6, we're going to see all of our rules combined. It's very exciting. So, this 2 gets handed out to the m and to the n. There's no exponent on the other parentheses, so we will see m to the 3 times 2, n to the 2. I'll just keep those parentheses there for now, even though they're going to not end up mattering. And we're going to have m to the negative 4, n to the 5th. This is m to the 6th, n squared, m to the negative 4, n to the 5th. Now hopefully you remember your other rule from yesterday. When you multiply powers with the same base, you add the exponents. So rearranging, we have m to the 6 plus negative 4, n to the 2 plus 5, and so that becomes m squared n to the 7th. And our last problem, hopefully, these look like a mess when you look at them, but hopefully you can see that it's all just kind of simple multiplication. So here our negative 4 exponent gets handed out to the 2 and to the y cubed, and here the 4 gets handed out to the x cubed and the y to the 4th. So we have x to the 2 times negative 4, y to the 3 times negative 4, times x to the 3 times 4, times y to the 4 times 4. That's x to the negative 8, y to the negative 12, x to the 12, y to the 16th. Combine the same bases together, so we have x to the negative 8 plus 12, because now we're adding exponents, y to the negative 12 plus 16. So we're left with x to the 4th power, y to the 4th power. So again, hopefully you were pausing this. If anything was unclear, if you had any aha moments, you can rewind the video, and I hope this helps. Tomorrow you'll have a similar sheet as this, but with the answers blank for you to practice, and I will once again attach a video of me showing you how to solve them, so that if you get stuck, you have that to